Okay, so we're going to talk about using theorems of lines and transversals to do several different types of problems. So first thing I want to talk about is we have kind of talked about already that alternate interior angles are congruent in a previous video, and alternate exterior angles are congruent. We talked about all these different angle relationships and what they are. But that also works for most of them in reverse order. So say we know some angle relationships, but we don't know whether or not the lines are parallel. So these four right here, so it's including everything besides vertical angles, because vertical angles are kind of a special case, but the other four, if we can prove that that's true, if we know the alternate interior angles are congruent, then the lines have to be parallel, even if we didn't know that before. So if I look at this figure right here, and we're going to pretend that I don't know if these two lines are parallel or not, and kind of go about four different ways I could show that they are parallel. So if I look, I'll use the first one as an example. If alternate interior angles are congruent, then they're parallel. So I need to find two alternate interior angles in my figure, and there's a couple of options. I'll just go with angles C and F. So if angle C is congruent to angle F, then these two lines have to be parallel. And in this case, they are 62 degrees and 62 degrees. Because if the alternate interior angles are congruent, the two lines have to be parallel. The same idea with number two, we're going to use alternate exterior angles this time. So let's look at, say, A and H, or alternate exterior angles. So if angle A is congruent to angle H, these two lines have to be parallel. Now, if consecutive interior angles are supplementary, so if we look at this side, F and D are consecutive interior. So if angle F, or I guess the measure of angle F, plus the measure of angle D equals 180 degrees, then they have to be parallel. And 118 plus 62 is 180 degrees, so these two lines have to be parallel. And then if the corresponding angles are congruent, so let's say we look at A and E, they're corresponding. If angle E is congruent to angle A, then the two lines have to be parallel. So sometimes it's useful to kind of show things in reverse. We know the angles, we don't know about the lines. We don't know if the lines are parallel or not. So a couple of other ways of looking at that same idea are found right here. So put a check mark by all of the statements that guarantee that M and N are parallel. So I would start at A and say, okay, measure of angle 1 is 42 degrees, measure of angle 5 is 42 degrees. So 1 and 5 are corresponding angles. Corresponding angles would be congruent if the two lines are parallel, so I would say check, yes. And then I'd look at angle 4 is 64 degrees and angle 5 is 64 degrees, so 4 and 5. Well, 4 and 5 are consecutive angles, not corresponding, so they should add to 180, not be equal to each other, so I wouldn't put a check mark there. So this kind of goes through, and you can put a check mark by the ones that do show they're parallel and not put one by the ones that are not parallel. And then it's kind of a similar idea on number 9. We're given a lot of different pieces of information about this shape, and we want to figure out if any of the lines are parallel. So these two lines could be parallel. So is AE parallel to BF? That could be true or false. Is F or EF parallel to AB? That could be true or false. So that's basically what this question is asking. And we'd kind of go through these to decide if that's true. So I'll start AEF. So to find that angle, I start at A, go to E, then to F. So AEF is this angle. And BFG is this angle. So if these were my parallel lines and this was my transversal, then these would be corresponding angles. They'd be to the left of the transversal, below the line, to the left of the transversal, below the line. So that would mean if these are equal, which is the saying it is, that these two lines would have to be parallel. So AE would have to be parallel to BF. So I would say true. However, I have no idea about the other two lines yet, so we'd have to go through the other information given in number 9 to figure out if the other two lines are parallel. Another thing to look at is if we're given, let me switch over to this document. If we're given some binomials as angle measures instead of the actual angle measures. So we can still use some information that we know about angle relationships to kind of solve for x and y and figure out what different angles equal. So I do have to be careful. These two are vertical angles, so they have to be equal to each other. However, if I set 17x minus 70 equal to 3y plus 5, I can't solve for x or y because I have an x and a y. I'm not going to be able to get things by itself. So I need to start by looking, okay, this has an x in it, and this has an x in it, this has a y in it, and this has a y in it. So I'm going to compare my x angles and compare my y angles. So my x angles are alternate exterior angles, and alternate exterior angles are congruent. So 17x minus 70 has to be equal to 2x plus 5. So once I'm here, I can just use regular methods of solving equations to get x by itself. So I'm going to go ahead and add 70 to both sides and subtract 2x from both sides. So 17x minus 2x is 15x, and 5 plus 70 is 75. So to get x by itself, I can just divide by 15 on both sides. The 15's cancel. 75 divided by 15 is 5, so x equals 5. So let's say I wanted to figure out what this angle equaled. Well, 2x plus 5, I don't know how many degrees that is. However, I do know that x equals 5, because that's what I just found. So if I plug that in, 2 times 5 is 10, 10 plus 5 is 15. So this angle would be 15 degrees, which shows that this picture is obviously not drawn to scale, but you get kind of the idea. But then if I try and find y, these are consecutive angles, not alternate exterior or interior, and consecutive angles are supplementary, they're not congruent. So if I have two angles that are supplementary, that means they add to 180 degrees. So I could do 3y plus 5 plus 5y plus 15. So if I add both of those together, it should equal 180. And then I can go ahead and just kind of combine like terms, try and get y by itself. So 3y plus 5y is 8y, and 5 plus 15 is 20, and that's equal to 180. To get y by itself, I can subtract 20 from both sides, and these cancel, so I have 8y equals 160, and then to get y by itself, I divide by 8 on both sides, and 160 divided by 8 is 20. So y equals 20. So again, say I wanted to figure out what this angle equals, I could do 5 times 20, which is 100. 100 plus 15 is 115. And these two angles are corresponding angles, I believe, yes. So this one, or let's see, if I plugged, so this particular figure is a bad example because whoever drew it didn't draw it to scale. So I would probably just plug in the x and y values to solve for each one. But if you had a figure that was drawn to scale, then everything would match up. And these corresponding angles would be the same, and alternate exterior angles would be the same, and so on and so forth. So now I just want to go ahead and look at this figure for a minute. Angle 1 is equal to 80 degrees. So this is equal to 80 degrees. And now I want to go through and find all of these other angles and kind of explain how I knew that. So the first one is the measure of angle 1, which is given to me, is 80 degrees. And that's pretty easy to explain because that information was given. So that's all I'm going to say is the measure of angle 1 is 80 degrees because that information is given. But from here on out, we're going to have to find everything else. So we're going to explain kind of how we found it. So now it wants me to find the measure of angle 2. Well, all I know is angle 1, so I'm kind of looking at how angle 1 and 2 relate, and I can see that they're on a straight line, which means that these two angles have to be supplementary. So if I do 180 minus 80, this would be 100 degrees. So measure of angle 2 is 100 degrees because angle 1 and angle 2 are supplementary. And from the step above, I know that angle 1 equals 80 degrees, and 180 minus 80 equals 100. So I'm basically just kind of walking through my thought process at how I got to this final 100. Measure of angle 3, there's not a million, but there's several different ways that you could find angle 3. I'm going to go ahead and compare it to angle 1 because those angle 1 and angle 3 are vertical angles, and I know that vertical angles are congruent. So measure of angle 3 is 80 degrees because angle 1 and angle 3 are vertical. Vertical angles are congruent. And angle 1 is equal to 80 degrees, so angle 3 has to be equal to 80 degrees. Then I move on to measure of angle 4, which I can actually do using that same logic because 2 and 4 are vertical angles. So 4 has to be 100 degrees because angle 2 and angle 4 are vertical. And then I'm not going to take the time to write it, but vertical angles are congruent and angle 2 is equal to 100 degrees. So it's that same reason that we had up here. And then angle 5 and angle 6, I'm going to go ahead and just explain them and not write them, but if you're writing, I would love for you to write down what I'm saying. Angle 5 is right here, and angle 5 is an alternate interior angle to angle 3, which this should be 80 degrees. So alternate interior angles are congruent. So I would say that the measure of angle 5 is 80 degrees, so I'd put 80 right here, because angle 3 and angle 5 are alternate interior angles. Alternate interior angles are congruent, and angle 3 is equal to 80 degrees. Angle 6, and again, you may think of another way to do this, which is totally fine. You just have to have a valid logical explanation for why you're saying what you're saying. So I'm just giving you examples. You can write however you want, as long as it's a logical explanation. So angle 6, I can see is corresponding with angle 2. So I would say the measure of angle 6 is 100 degrees because angle 2 and angle 6 are corresponding angles. Corresponding angles are congruent, and angle 2 is equal to 100 degrees. So those are just a couple of examples, but I'll go ahead and let you decide how you want to explain that measure 5 is equal to 80 degrees and measure 6 is equal to 100 degrees.